Good morning, students. Myself, Vijay Shankar from ECE Department, JNTUK Engineering College. Today, we are going to discuss about the examples of convolution and the correlation. The different types of examples are there: graphical representation and mathematical representations, and sequence representation and tabulation method. Or the different types of examples are there in the convolution and the correlation. So we already discussed about what is convolution and what is a correlation. So once again, you can see what is a correlation means. Convolution. Convolution is used to find a common area between two signals or two functions. It is find the common area between the two signals or the two functions. The convolution f of t of two time functions f1 of t and f2 of t is designed. F of t is equal to f1 of t with the convolution of f2 of t and f1 of tau f2 of t minus tau d tau, or f2 of tau f1 of t minus tau d tau. Okay, so the convolution is a mathematical operation and the multiplication is one form of the convolution. So convolution is a mathematical operation and multiplication is one of the form of convolution. So 25 greater than 625, simply like that only. When the signals having some samples, there is a mathematical equation, my students. Okay, so f1 of tau we can take it as a 25 and f2 of tau is a 25, and the second it is a f2 of minus tau. So f2 of minus tau is a reverse, the folded function. Don't take it is a 5 and a 2. F of minus tau and f of tau is reverse operations for the positive values and the negative values. And f2 of t minus tau is f2 of minus tau shifted right side by t seconds. Here t is varied from minus infinite to infinite. Okay, my dear students. And see one of the example here, the procedure how we can find the examples when we are giving any two signals to find the convolution by using the graphical representation. So f1 of t and f2 of t convolution formula is f1 of tau f2 of t minus tau d tau. Here the independent variable convolution integral is tau. So replace t by tau to get f1 of tau and the f2 of tau. And the second step, f1 of tau is the first function and f2 of t is the second function. The second function f2 of minus tau is a mirror image of the f2 of tau. So mirror image. How we are calling this as a mirror image means let the function is like this f2 of tau as a step function is given, and f2 of minus tau. F2 of minus tau is folded function. Folded function means a reverse. Positive as negative, negative is a positive. The folded function. It is folded at the 0 because it is a minus tau. If there is any minus 1, minus 2 or something is, you have to fold it at that particular value. And third function, f of or the f2 of t minus tau represents the function f2 of minus tau shifted to right. After the folded function, the samples are shifted towards the right by t seconds. The t is varied from minus infinite to infinite, and find the common area between the two functions. Common area between the two functions. The value of convolution is obtained at different values of t and may be plotted on a graph. Okay. So find the Fourier transformation of the two functions we given, the f1 of t, let it is a f1 of tau. I'm changing as f1 of t as a f1 of tau, and f2 of tau is f2 of t is f2 of tau with the amplitude is a. And step 2, the step 2 is the f2 of minus tau. So f2 of minus tau. So a into g of minus tau. What I am assuming is a g. So don't use the G also. Directly you can write as in terms of the F only. So G is a function of even function because folded at the origin means F2 of minus tau. The 0 to 5 will get in this one, and minus 5 to the 0 will get the same function because it is a symmetric. The given graphical representation of the F2 of t is a symmetric function because it is an even function. Minus 0 to the same value and 0 to 5 is also the same value, even if it is a folded also. Okay, and f1 of tau is equal to at t is equal to minus tau. At t is equal to minus tau, not the minus tau, sorry. So t is equal to minus infinite. T is equal to minus infinite means a minus infinite minus 5 and the minus infinite plus 5. So the values is I am taking it is a minus infinite. All it is added minus infinite minus 5 and 0 minus infinite and plus 5 minus infinite. Again it is a will get it is a minus 5 0 and the 4 0 5 the tau. Now I am taking that it is a convolution of the two signals. The convolution of the two signals f1 of t and the convolution of f2 of t, because it is in the values of minus pi to 5, but here the values is in the minus infinite minus 5, minus infinite and plus 5. So both are, it is not at the same values when it is a multiplied. So at minus 5 here the value is a 0. At plus 5 here the value is a 0. At 0 the value is a 0. But minus infinite in this function is a 0. So the convolution between of these functions is a 0 values. Okay. So you'll get the little bit confusion here. What I am saying, when I am taking that t is equal to minus infinite, t is equal to minus infinite, it is a minus, let us take there is a value of minus infinite. Okay, and minus infinite minus 5, minus infinite minus 5, there is a value is here, and minus infinite plus 5, there is a value is here. This is a given signal, the f1 of t, let us take it. Okay, the another signal is there here, f2 of t. What is the f2 of t having the values? Here the 0 is there, let us, and 0, 5 plus 5 and the minus 5 having the values now. So at plus 5 there is no any value. A into 0 is a 0. At 0 a into 0 is a 0. Minus 5 a into something here is 0. But minus infinite and minus 5, minus infinite and minus 5, here the 0 is there. So value into 0 is a 0. Having some value into 0 is 0 and having some value into 0 is 0. Totally the convolution becomes a 0 value. Understood by the students? Similarly, at t is equal to minus 5 and t is equal to minus 4 and t is equal to minus 3, minus 2, minus 1 and the t is equal to 0. So on going to the finding out shifting of the values, shifting the values here. When it is shifted, t is equal to minus 5 means t is equal to minus 5 minus 5. It becomes of minus 10. And minus 5 and plus 0 is a minus 5. And the 0 is there. Okay, my dear students. See, this is a function. I'm taking this function, adding of the t and shifting towards it. See, this is a third step I am using. f2 of t minus tau. T minus tau. These are values of tau, minus 5, 0 and 5. I'm adding the t here. What is a t? First of all, I am assuming minus infinite. And there is no any change in the f1. f1 is the same. f1 is a same value, only there is a shifting occurs in the f2 only. There is a shifting occurs in the f2. In that f2 also, after folding, we are adding the t. We add the t values and it is shifted towards the right side. Minus infinite, I'm adding for the minus 5 and the minus infinite, 0 minus infinite and the 5 minus infinite. multiplying the two functions, the value is a 0. The same way, I'm taking here t is equal to minus 10. T is equal to minus 10 means what is the value? T minus tau. T minus tau. Minus 10 and the minus. See, the value of f2 of t, sorry here, either 0, plus 5 and minus 5 for f2 of minus tau. Okay, I need the value is f2 of t minus tau. Okay, my dear students, these are tau variables, t minus tau. What is the t I assume here? T is equal to minus 10. T is equal to minus 10. F1 is the same. F1, there is no any change in the F1. F1 of t is minus 5, 0 and 5 with the amplitude is A. And F2 of minus tau, after folding of the F2 of minus tau, the same here. Whatever the F2 of tau, F2 of minus tau is also same because it is an even function or it is a symmetrical for plus values and the minus value. But now I am taking the t is equal to minus 10. So adding of for minus tau, the t, what is the t minus 10 and the minus 5? Minus 10 minus 5 is a 15. 0 and minus 10 means minus 10 here. And minus 10 and plus 5, minus 5. Okay. So actually this is not the arrow mark here. This is a straight line only. Okay. Up to this, now the new values. You can multiply these two. Now the function I will draw here. You can understood. See the minus 15, minus 15, minus 10, and minus 5. Okay. This is a f2 of t minus tau, the variable of tau. Okay, the amplitude is also A only for these three values. Now, I'm multiplying with this f1 of tau. There is no any change in the f1 of tau. What is the value here? It is a 0 here. Minus 5, 0, and the 5. Now I can multiply. Minus 15, there is a is there. But here, minus 15, the 0 value. And at minus 10, here the value is A, but here it is a 0. But at minus 5, and here also the minus 5, here the A is there. And here also the A. Means A into A is a square. A into A is A square. At the same value, there is a two values is overlap here. Two values is overlap. So we'll get this value is A into A square. For the f1 of t, the convolution of f2 of t is equal to, now the value is A into A is a square. A into A square minus 2. Okay, got it. And at the 0, what is the 0 here? The 0 here, the 0, and the value is A into 0, 0. And for the 5, the value is A here, but here it is a 0. So after multiplying, we'll get add the minus 5 only. Add the minus 5, we'll get the A square. Add the minus 5, it is a square. Got it, my dear students? So see, this is the same thing, the minus 15, minus 10, minus 5, 0, and 5. See, add the minus 5 only, there is a overlapping occurs here. Exactly. Following. And coming to the t is equal to minus 9. T is equal to minus 9 means the f1 of t, f2 of t becomes f2 of t minus tau. F2 of t minus tau is now the becomes of t. What is the t now? I am assuming the minus 9. Already we have the minus 5. Minus 9 and minus 5 is the minus 15. Or the minus 15, minus 14, minus students. Minus 14. And minus 9 and the plus 0 is minus 9. What the minus 9 here? And minus 9 plus 5. So minus 4. Minus 9 and plus 5. Minus 4. Okay. We got these values. Now, this arrow mark you are always representing at the 0 only. So remove this here and keep this a value here. And there is a 0. Exactly. It starts f1 of t is a minus 4. And arrow mark here. There is a arrow mark of f2 of t. And here the arrow mark you can take it as f2, f1 of tau. The 0 value, here also the 0 value. Now I am taking it as a minus 5, 0 and plus 5. Minus 5 is here. So minus 4 will get here, minus 4. There is a overlapping occurs in between of minus 4 and the minus 5. See, these are overlapping. Remaining all the functions you can multiply. The minus 14 here the 0, minus 14 0, minus 9 is a 0, and 0 here the 0 value is a, but here the 0 value is a 0, and the 5 the value is a, but here the 5 is a 0. So only there is a overlapping occurs in between of minus 5 to 4, minus 5 to minus 4, minus 5 to the minus 4. So the same thing here, the minus 4, 5 to the minus 4. In this, you can multiply the values a into a only, because if the magnitude is a here, and here also the magnitude is a. A into a is a square. Okay, a into a is a square. Like that, the a into a is a square, but the limitations is now minus 5 to minus 4, minus 5 to the minus 4, upper limit is a minus 4, and lower limit is a minus of minus 5 is a square into 1. Now we got the a square. Okay, my dear students. And similarly, minus 8, still it is moves towards the right side. So from minus 15 and minus 14, now it is a minus 8 and minus 5. Minus 8, minus 5, minus 8, minus 5. You get the minus 3. Not the minus 3, minus 8 and minus 5 is a minus 13, my students. It is a minus 13. And minus 8 plus 0 is a minus 8. And minus 8 plus 5 is a minus 3. Here the minus 3. And f1 is varies from the minus 1 and the minus 5 and the 0. So it moves towards the right side. After adding of minus 8, from minus 14 to the minus 13. And minus 9, it becomes of minus 8. And minus 4 becomes, it is a minus 3. So one sample is shifted. And previously also see here the minus 15, it moves one sample. Minus 10 and the minus 9 is one sample. And minus 5 is now it is moves to the minus 4, one sample. So means here the from left hand side to the right hand side, the f2 of t is moving, and with the comparing with the f1 of t, it's a overlapping occurs. That overlapping, again it is a into a here, a square, but the limitations is the difference. Minus 5 to the minus 3. And here also, you see the minus 5 and the minus 5. A into a. A into a d tau. What is a into a? Is a square. Is a constant with respect to the tau. The tau is there. Tau. And the varies from minus 5 to 5. Minus 5 to minus 5. So a square into minus 5 and the lower limit is minus into minus is a plus 0. So in this condition, it is a value is a 0, my dear friends. In this condition, is a value is a 0. The convolution is a 0. The previously infinite is also 0. But here the a square minus 4 plus 5. Now the overlapping occurs from minus 5 to minus 3. So minus 5 to minus 3, a square minus 3 is upper limit and lower limit is minus of minus 5. So minus 3 plus 2 is a 2a square. Here the a square and here the 0. For t is equal to minus infinite, the value is also the 0. Now I am taking the minus 7. Again, it is shifted towards the right side. See, the minus 5 is already we have. Minus 3 becomes minus 2. Minus 8 becomes minus 7. Minus 13 becomes minus 12. Minus 12. Here also a into a. It is multiplied. A into a, but the limitations is from minus 2 to the minus 5. So upper limit is minus 2 and minus of minus is a plus 5. 5 minus 2 is a 3. 3a square. And so on. Minus 6, you get the 4a square. Because it is a overlapping occurs is from minus 5 to the minus 1. Goes on, one sample is shifted towards the right side and it is a overlapping occurs. Got it, my dear students? Graphical representation. T is equal to minus 6. Then t is equal to minus 5. T is equal to minus 5. Here the minus 5 to the 0. Minus 5 to the 0. A square into 5. Previously, 4a, we got the a square, 2a square, 3a square, 4a square, and 5a square, 6a square, 7, 8, 9, 10. When the t is equal to minus 4, one sample, minus 3, one sample, minus 2, again it is a one sample, minus 1, again it is a one sample, and t is equal to 0. And t is equal to 0 is minus 5 and the minus 5. Fully it is overlapped with the same values. 10a square. Again the t is equal to 1. If the t is equal to 1, it moves towards, here the minus 5 is for the f1 of t. And this minus 5, there is no any change in the minus 5 here. But it moves to minus 4, minus 3, minus 2, minus 1, 0, 1, and so on. Now the limitations is minus 4 to 5. Now again it is a decreases. Okay, my dear students. Up to this it is increases 10a square. Then after t is equal to 1, it is decreases because of limitations is minus 4 to 5. Minus 4 to 5. 5 minus of minus 4 is a 9a square. Next, 8a square, 7a square, 6a square, 5a square, and 4a square. And similarly, for 7, 3, 8, 2, t, 9, 1, and 10 is equal to 0. So on. Following, my dear students. Now, you can take all the functions from minus infinite is a 0. We got all the functions from, I'm taking the convolution here, f1 of t with the convolution of f2 of t. What is a minus infinite value? 0. And at minus 10 also. Minus 10, here I'm taking the minus infinite is a 0. Minus infinite is a 0 here, my dear students. And similarly at the minus 10 is also 0. It starts at the minus 9 a square, minus 9, 1, either 2, 3, and so on. Goes up to the 10, and again it is a decreases. Okay. So 10, I will saying here the minus up to so on. Minus 10. What is a minus 10 value? Again, that also the 0. All the values is 0. And minus 9. Minus 9 is a square. The value is a square. And minus 8. 2 into a square. Okay. 2 into a square. Minus 7. Okay. And minus 6. Minus 5. Minus 4. Minus 3. Minus 2. Minus 1. and the 0. Okay, minus 8 is a 2a square and it is a 3a square, increasing 3a square, 4a square, 5a square, and 6a square, 7a square, and 8a square, 9a square, and at the 0, t is equal to 0, it is a 10a square minus. The 10a square we got the 10a square, and a t is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 10. What is a 1? A t is equal to 1, the value is 9a square, means it decreases. Slowly it is a decreases here. 9, 8, 7, 6, 5, 4, 3, 2, 1, and the 9, 10 is a 0. And my plus infinity is also 0. So you'll get after the curve, slowly it is a decreases. It is also symmetric. For the two functions, f1 of t and the f2 of t is given from minus 5 and the minus 5 is 0. And it is also minus 5 and the 5 is a 0. f1 of t and the f2 of t. The convolution of f1 of t and the f2 of t is the graphical representation. It is also the symmetric, starts from minus 10 to the 0 and 1 to the 10 is a 0, my dear students. So I did it wrong here. Graphical representation. Again, I did it's a 0 at the 10. Okay, like this. Okay. You see the same graphical representation we got for all the values of t. Got it, my dear students? See what you have to do. The f1, keep the f1 of t is the same. There is no any change in the f1 of t. And take the f2 of t and you can fold it the function. In this example, after folding the f1 of t, also the same value will get at minus 5, 0, and 5. Now you can take that f2 of minus tau is a folded function, and take the f2 of t minus tau, adding of t from minus infinite to the plus infinite. Okay, take all the values approximately, then shifting one sample towards the right side. After adding the t, shifting one sample towards the right side. If there is any overlap with others, take that range and substitute in the integral value and apply the integral to get the value at t is equal to something. So finally, add all the graphical representation from minus infinite to infinite to get the symmetric as they given f1 of t and f2 of t is also the symmetric. Got it, my dear students? It's a very important. The convolution. Again, we did one example in the graphical representation. Mathematical way of combining the two signals is already we discussed with this one. So z of t, it is used to express the input and output relation of a linear time invariant system. If two functions x1 and x of t and y of t in a time domain are defined, then the convolution of z of t. If I am taking the x and y as two functions, z of t is a convolution between of the two functions. Integral minus infinite x of tau y of t minus tau d. Or you can also interchange y of tau the x of t minus tau d. Again, the same equation. Convolution in time domain. The convolution in time domain is equal to the multiplication of their frequency in the domain. This is a convolution theorem, my students. Convolution theorem, or the one of the property of Fourier transformation. Convolution in time domain function. Convolution in time domain function. Okay. using the shifting property, frequency shift property, we'll get x of t and the y of t. The Fourier transformation is x of omega and y of omega. This is a theorem of convolution theorem, time convolution theorem, or convolution in time theorem. So now the convolution in the frequency is a modulation of the multiplication. Multiplication of two functions in the time domain is equivalent to the convolution is their spectrum in the frequency domain. Okay, my dear students, the product of two time domain functions, x of t and y of t. What is the Fourier transformation? The convolution of the two frequency domain. X of omega, the convolution of y of omega, and multiplied with the 1 by 2 pi. 1 by 2 pi, because inside, whenever you go to prove the convolution frequency domain, you have used the inverse Fourier transformation. Okay, we already know how we can derive this convolution in frequency domain, or otherwise is one of the property, my dear students. One of the property. The property is a modulation or multiplication theorem. Okay, and graphical convolution. Graphical convolution. Another example you can see, the convolution by inspection provides the information needed without complicated calculations. This convolution by inspection procedure is called the graphical convolution. The procedure is x of tau is the first function where an independent variable of t is replaced by the dummy variable of tau, because the convolution formula itself the x of tau and y of t minus tau d tau. Okay, so given the function x of t is change the value is a dummy variable with the tau, and y of t as a y of minus tau is a mirror image of y of tau as a flipped. Flipped means is a folded function, or it is also called as a folded function. Then after, y of t minus tau represents the function y of minus tau is shifted towards the right side by t seconds. Now for every time you can add the t samples and shift it towards the right side. For a particularly of value of t is equal to a, the integration of product x of tau, y of actually it is a t minus tau. What is the t here? The a minus tau represents the area under the product or the common area product. So integral minus infinite x of tau y of a minus tau d tau is nothing but the convolution of the signals x of t and the y of t at t is equal to a. And the procedure is repeated for different values of t. For negative values of t, the function of y of minus tau is shifted left by t seconds. The value of convolution of time at different values of t, that is positive and the negative values. Okay, this is a procedure you have to follow when we are going to find the convolution of the two signals in the graphical way, in the graphical representation. The example given here, the example, the x2 of t and x1 of t. The convolution of functions of x1 and x2 of t. I'm taking the x1 of tau. x1 is, there is no any change in the x1, only there is a change occurs in the x2, my dear students. x2 is given as a graphically a linear function, not the linear, it starts from the 0 here. Okay, it's a 0 only. 0 to 4. This is 0 to 4. This is a value at x2 is given, x2 of 4. So linear function. Okay. 0 to 4. Now, this x2 of t or x2 of tau is shifted, not the shifted, folded function. Then is a folded function means exactly it is You'll get from -4 to -4 to 0. This is of x2 of minus tau. I'm changing this dummy variable as t as minus tau, minus t is tau, and minus tau after the folding function. It starts from the -4 to the 0. Now you can multiply this function with x1 of tau. What is the x1 of tau? Varies from -1, 0, and 1. -1, and 0, and 1. Let it is the magnitude is a 1. Here it starts from the -4. -4 means slowly it decreases. At -3, the value is a 3. -2 is the value is 2. And -1 is value is a 1. And 0 is a 1. So, but here the -3, -2, -1. So, overlapping occurs here when I multiply these two functions like this. It starts from the -4, -3, and -2, and at -1 the value is 1. So 1 to 0. What is the integral here? -1 to the 0. The two functions. So the two functions, the value is a 1 or 1 into d tau. 1 into d tau. 1 into d tau 1, the integral 1 is a tau. Upper limit is a 0, lower limit is a -1. So 0 minus of -1 is a +1. For the first integral, if I am multiplying at the t is equal to 0, this is at the t is equal to 0, my students. T is equal to 0 after the folded function. At t is equal to 0, the value of convolution is a 1. Got it, my students? See, the remaining values of what they taken here. Again, it is a shifted -1 to the 1. So -4, it becomes of -3. The second function at a is equal to 2 and a is equal to 3 and a is equal to 0, I take it. A is equal to 0 is a 1 and a is equal to 1, we can take a is equal to 1 means it is one sample is shifted towards the right side. How it is, if this is a function for the t is equal to 0 minus 4 for x2 of minus tau, and now I am taking it is a x2 of t. T is equal to, if I am taking the 1 minus tau, what is the 1 we can add here? The -3, it becomes -3. So it starts from the -3 and end it's a -1. Here the -1, so 0. Okay. And what is the x1 of t is given? X1 of t is given from the -1 to the value. -1 to. So -1 to 1. Here the 0 value is there for the x1. There is no any overlapping occurs here. Following my students. It's not the correct, I think. -3 and at the 0. 0 here we'll get is 1 is something at a is equal to 0. A is equal to 1, a is equal to 0, it is a value the same thing. The overlapping occurs here. And similarly, the a is equal to, it is shifted off towards -3 again, and it is a -2 towards the right side. Still again, it is a -2, -1, and a 0, and up to the value is a 2. Now there is a overlapping occurs, and here again the another shifting from -1 to 3. so on goes, increases. Okay, my dear students. So 1 and the 0. 1 and the 0 means we can add the 1 here. It becomes of minus 4 plus 1, my dear students. Minus 1 plus 4. Add the 0 plus 1. Okay. So minus 3 to 1. It varies from minus 3 to 1. It is not the minus 1. So it is minus 3 to 1. 3 to 1, because after the 0 there is no any minus 1. So I did for wrong here. The value is minus 1 here, plus 1. Once again I will explain. What we get for at t is equal to 0, at t is equal to 0, the 4 and it is a 0 here, minus 4. And what is a x1? X1 is varies from minus 1 to 1. Now there is a overlapping occurs here. Overlapping occurs at t is equal to 0. Now at t is equal to 1, at t is equal to 1, for these two values, I will write these two values here. This is a minus 4 and this is a 0, 0. For to these two values, you have to add the t as a 1. T is equal to 1. Minus 4 and minus 3. Minus 4 plus 1 is a minus 3. Minus 3. And 0 plus 1 is a 1. So the graph now here like this. The f1 of, not the f1, x1 of t is the same. There is no any change here. X1 of t. X1 of t will get this. The overlapping occurs at this stage. The overlapping is occurs in this stage. Now t is equal to, see the minus 3 and 1. One sample is shifted. And then at t is equal to 2. At t is equal to 2. Already we have minus 1, 0 and 1 for the x1 of t. Now what is the x2 of t? Add the 2 for the first function. So minus 4 plus 2. Minus 4 plus 2 is a minus 2. So it starts from the minus 2. And it's 0 plus 2 is a plus 2 here. So again, it is from the 2 to the value like this. Now the overlapping occurs here. The overlapping occurs here. Okay, my dear students. Then after, at t is equal to 3. T is equal to 3. The x1 is the same thing. Minus 1, the 0 here. Sorry, it is 1. 1. Now we can add this 3 for the first function. Minus 4 and plus 3. Minus 4 and plus 3 is a minus 1 only. Minus 1 and slowly it is decreases. Here the minus 1 will again you'll get at minus 1 and 0 plus 3. So 3 will get here. So decreasing like this. Again, the overlapping occurs here itself. Overlapping occurs here. And t is equal to 3. And so on decreasing again. That t is equal to 4 and t is equal to 3. So where it is starts here at the minus 1. At the minus 1 here. Minus 1 means a minus 1 to the 0. Minus 1 from minus 1 to the 0. before there is no any overlapping here. In all the observe here -1 0 and here also -1 and 0 and -1 0. So start from the -1 and slowly it goes on decreasing until at which value is again if I am taking the t is equal to 4. T is equal to 4. What happens? -4 plus 4 is a 0. -4 plus 4 is a 0 and 0 plus 4 up to so on it is a 4. So -1 and +1. -1 plus 1. Here there is a overlapping between the 0 to 1. Still it is t is equal to 5. If t is equal to 5, I can add here for the first function -4 plus 5. -4 plus 5 is 1, 1 and 0 plus 5, here the 5. So 1 and the 0. So now there is no any overlapping here. The -1 and the 0 exactly at 1. For upper limit is a 1 and lower limit is a 1. 1 minus 1 is a 0. So at 5 value it goes to the 0. We start from the -1 and ends at the t is equal to 5. T is equal to 5. So here see the symmetric values go on increasing and decreasing. Goes on increasing and the decreasing in the graphical representation. See the overlapping and find the values. -1 is the 0 and 5 is also the 0. And at the 0, 1, 2, 3 and 4 slowly it is increases and again it is slowly it is a decreases. Okay. The two examples what we seen, what we discussed today's class, in this today's class, my dear students, these two are in the continuous time functions. It's somewhat difficult for the continuous time if they given the continuous time. If you go for the discrete time function, the convolution is very easy because no need to see the overlapping or functions. We have the discrete functions means at particular intervals of particular values on at instance of time. It is very easy in the discrete time functions to find the convolution of the two equations. Okay, the tomorrow class we can see that the convolution for the discrete time sequence. Okay, my dear students. Any questions? Okay, my dear students, thank you.